Thank you, Ellie. It's great to see Google Play for families. As a father of two, I've had my share of Dora, and I hope all of you get to enjoy that experience as well. So you've heard how developers can build amazing experiences on top of our platforms. For us, we really want to enable the next generation of developers as well. A lot of us take for granted the skills we have in this room. You earlier heard about the next billion users coming online. It is important we empower others to become developers so that they can build the next set of experiences. So we've been working with Udacity. Udacity is a leading provider of massively scalable online education. And so I'm very excited to announce today we are launching the Android Nano Degree. It is a 6-month course for just $200 a month, and we cover the entire life cycle of Android development, all the way including details like Google Play services, material design, et cetera. Google has invested over $4 million in developing this curriculum, and we hope many folks take advantage of this. At this point, we're going to shift gears and take a look ahead, talk about the future of computing. We have talked about how mobile is at the center of your digital experience. But there will be cases when you want computing to be much more immersive in context for you. Not all of your computing experiences is going to be looking at a small black rectangle in front of you. Think about the icebergs of Greenland. You do want an experience as if you are there and you can experience the real world for all its richness, depth, color, and glory. So we've been thinking a lot about how to bring the real world to users in a more immersive way. We've always cared about it. Google Maps has been doing Street View, imagery, trying to capture the real world. So we started our efforts here with Google CardBoard. The CardBoard team was a 20% project. We launched it at last year's Google I/O, and they've been thinking hard about VR and how to get a much more immersive computing experience. To talk about that, I'm going to invite Clay Bauer onto the stage.
As Sundar said, a year ago, on this very stage, we introduced Google CardBoard. And our goal with CardBoard was to make virtual reality available to everyone. And so we started with a piece of cardboard, some Velcro, we added some lenses, and a rubber band. And amazingly enough, that was all you needed to turn your smartphone into a fully functional VR viewer. And there's been incredible excitement about CardBoard ever since. What began as a single open design has turned into an entire ecosystem of manufacturers, making cardboard in all shapes and sizes. There are over 100 apps, hundreds of apps, on the Google Play Store that are compatible with Google CardBoard, including apps from folks like Jaunt and Verse, who are actually here with us today. And people keep finding new and creative uses of cardboard in VR, campus tours, art shows. One guy even proposed to his girlfriend with the help of cardboard. And I'm not actually totally sure how that worked, but the important thing is that she said yes. Today, I'm proud to say there are more than 1 million cardboard viewers out there in the world. And it's what we dreamed about when we folded our first piece of cardboard, immersive experiences just like these for everyone. And we really couldn't have done it without your help. Everyone who folded your own cardboard, who built an app, who filmed a spherical video, thank you. Today, I'm really excited to give you a glimpse of what's next for cardboard and for our larger efforts in VR. There are 3 things I'd like to share. And the first of those is an improved cardboard viewer. Now, the original viewer, it was great, but phones, turns out, got a lot bigger in the last year. And so the new design fits phones with screens as large as 6 inches. The magnet button, if you remember, was a clever way to do input, but it didn't work on every phone. And so we've replaced it with one that does, one that's actually made out of cardboard. And now, instead of it taking 12 steps to assemble, it takes just 3. So viewers are on sale today from partners. And of course, if you're here at Google I/O, just like last year, you'll get one immediately after the keynote. Okay, so it works with any phone, it fits any phone, the button works with every phone, but the software, the CardBoard SDK, it needs to work with every phone too. And so as of today, the CardBoard SDK for Unity will support both Android and iOS. So if you're creating a VR experience and you want to bring it to everyone, we think CardBoard can help. That's the CardBoard update. Lots of manufacturing partners, hundreds of apps, over 1 million viewers. And it's still just a piece of cardboard. Second thing I want to share today is about how we're bringing VR and its unique ability to take you other places and bringing that to some place that's pretty special. And that's the classroom. Just think about your favorite field trip growing up. There's something amazing about visiting a place, seeing it up close, experiencing it with your own eyes. But of course, the school bus, it can't go everywhere. It can't go to the moon, it can't go to another country and back in a day, can't go to the bottom of the Pacific Ocean. But VR can help take you those places, which is why today we're excited to announce Expeditions. So Expeditions lets teachers take their classes on field trips to anywhere. Here's how it works. So a box arrives with everything that you need to travel. Cardboard and phones for every student, a teacher tablet, and all of these devices are synchronized so that then when the teacher chooses a place, the entire classroom jumps there together. And the response from students and teachers has just been incredible. Let's have a look.
You could pick anywhere in the world that you want to go. Where would you want to go?
I would like to go to the moon, Thailand, ancient Greece,
India, to Nigeria, my homeland.
one or maybe all of the 7 wonders of the world. When you explore different places, you have the chance to actually learn something new.
You want to be able to show the kids that there's something outside of your community that you could go to and learn from, and that there's other places you can visit.
All right, so let's do our objective and we'll talk about the lesson for today.
We're going to take a field trip to Verona, Italy, to see the place where Romeo and Juliet lived.
I'm going to take you on this field trip under the water. Okay, you guys ready? Pick up your devices.
And look in your cardboard.
What is that?
I see a shark.
It allowed us to go somewhere we wouldn't normally be able to go.
Are we in China?
This is the Great Wall of China.
We got to see the place itself so we could actually understand what she was talking about.
How long would it take to walk the length of the Great Wall of China?
So much more enriching than just showing them a picture or just having them read about it.
This device can actually make us go to places that we've never been before.
It brings the lesson to you.
You have to see it for yourself to believe it.
There's so much other places to see, so you know that it's never going to end.
So thanks to an incredible group of educators, hundreds of classes all around the world have already gone on expeditions. And today, teachers who want to create their own, who want to bring expeditions to their school, can sign up online. Now, we're also partnering with some amazing organizations like the Planetary Society, the American Museum of Natural History, and the Palace of Versailles to create new expeditions and bring those to schools around the world in time for back to school this fall. So that's expeditions, field trips to anywhere for every classroom. Thanks. Thank you. So, the third and final thing I want to talk about is about capturing and sharing these real-world experiences, like the Great Wall or a coral reef, in an entirely new way, one that looks and feels like you're actually there. Because the world is filled with all of these awesome places and events like Great Barrier Reefs and Golden Gate Bridges and birthday parties and mountaintops. But there's a problem. If you can't actually be there, if you want to go back to a place or a time, then your experience is pretty limited. Because cameras kind of only capture the world like this. It's like watching a flat version of the world through a tiny little window. And if you want to capture something that's truly immersive, there are really only a handful of very custom camera rigs in the world that'll do the job. And even they have their limitations. We want to change that. We want to put professional, previously impossible tools in the hands of any creator who's motivated so that they can capture the world around them and then share it in a way that lets all of us jump to the top of that mountain, jump to any place or event on the planet, and experience those sights and sounds like we're actually there. So today, we'd like to preview something that we call Jump. Jump enables any creator to capture the world in VR video, video that you can step inside of and make it available to everyone. It has three parts: a camera rig with very specialized geometry, an assembler which turns raw footage into VR video, and a player. Let's start with the camera. So the rigs that we've built, they include 16 camera modules mounted in a circular array. And you can actually use off-the-shelf cameras for this if you want. And you can make the array out of basically any material. We've made one out of 3D printed plastic, one out of machined metal, and for good measure, of course, we also made one out of cardboard, and it worked. What's critical is the actual geometry, and we spent a lot of time optimizing everything: the size of the rig, the number and placement of the cameras, their field of view, relative overlap, every last detail. And we seem to be losing the slides here. Every last detail. And now what we want to do is share what we've learned with everyone. So just like we did with cardboard, we're going to be opening up the camera geometry with plans available to everyone this summer. So anyone who's motivated will be able to build a jump-ready camera. Now, of course, if you're a pro and you've done filming with multiple cameras, you know that it's kind of complicated. You need synchronized recording, exposure control, and so on. And so we thought it would be good if someone who really knows how to build a great camera could help out. So we called our friends at GoPro. And today, I'm excited to announce that GoPro plans to build and sell a jump-ready 360-degree camera array. Now, GoPro, of course, has enabled people to capture some of the world's most awesome experiences, including spherical content. And they're bringing their camera expertise to the jump-ready rig, which will include shared camera settings, frame-level synchronization, and other features that will allow all 16 cameras to operate as one. Here's what it looks like. So GoPro's actually here with us today, and they brought one of their rigs, and it's in our I/O sandbox if you want to check it out. So that's the camera geometry. Next up is what we call the assembler. And this is where the Google magic really begins. The assembler takes 16 different video feeds and uses a combination of computational photography, computer vision, and a whole lot of computers to recreate the scene as viewed from thousands of in-between viewpoints everywhere along the circumference of the camera array. And we then use these in-between viewpoints to synthesize the final imagery, stereoscopic VR video. Let me show you an example of how the assembler creates one single frame of VR video. So first, we take the raw camera data and we do a rough alignment. Next, we perform a global color calibration and exposure compensation, and things start to look a bit better. But if we zoom in, you'll see that there are still seams between some of the images, like here. To fix those, our algorithms use information about the underlying structure of the scene to perform a three-dimensional alignment. And the 3D alignment works by compensating for the depth of different objects in the scene, like this. And it's this understanding of depth that also enables us to create all of those in-between viewpoints, which you can see here. Like this. It's pretty cool. It's a fundamentally different and more advanced approach than anything else we've seen. And unlike other solutions, you don't see borders where the cameras are spliced together, and you have beautiful, accurate, depth-corrected stereo in all directions. Now, we've actually built a bunch of these cameras and sent them to places all over the world, from the Google campus in Mountain View to Iceland to Japan, and we've captured some really beautiful places. And I have to say, you got to see these properly in VR, which you can do at our booth. But let's see some footage here on stage. Again, wait till you see this footage in VR. Near things look near, far things look far, and you can look all around you. It just feels like you're there. Now, assembling footage like this takes thousands of computers, and we want to make this processing power broadly available. So this summer, we'll begin making the Jump Assembler available to select creators worldwide. But this leaves one question. Where are people going to watch this stuff? How are we going to make it so that anyone can experience it? And we've been working on something for that too, and we call it YouTube. So starting this summer, YouTube will support Jump. So if you want to experience VR video, all you need is the YouTube app, your smartphone, and some cardboard. Now, in the meantime, starting this week, you can try out basic, non-stereoscopic 360 content in YouTube and cardboard. That's Jump. An open camera design with a fully integrated version from GoPro on the way. An assembler that turns raw footage into VR video with the help of thousands of computers. And a player that everyone already has, called YouTube. All of this will be available this summer, and I am so excited to see what you all create. And there you have it, a glimpse at our efforts in VR. Jump, it's about capturing the world's places in VR video and giving everyone the chance to experience them. Expeditions, which lets teachers take their classes on field trips to anywhere. And then, of course, Cardboard, where we got started. The beginning of our journey. Cardboard is about VR for absolutely everyone. We hope you'll come explore with us. Thank you.